Thank you, Mike, and thank you for all your leadership. As Mike said, this is something that brings us all together as parents, as Americans. Linda, thank you for all your good support and passion behind this issue. Mike Kelly, thank you for all your efforts. You know what gets me up every morning to work on this issue are really two groups of people. One group are the parents and family members of kids who fought so courageously against pediatric cancer and fought under incredibly difficult circumstances, who kept their spirits up to the end but haven't made it. And those parents and those family members have taken that pain and that tragedy in their personal lives and dedicated themselves to trying to make sure that doesn't happen to any more kids. And without that passion in memory of those kids, we would not be here today. And then there's another group. They're the families and kids who have battled different forms of childhood cancer and survived, and who right now today are contributing in so many ways to our society. I have constituents who went through and battled these issues, a fellow by the name of Matt Grossman, who today is helping kids with autism, graduated from college. And what those kids tell us is that if we make the investment, if we fight this over time, we will prevail. Because those are kids who have survived because of the advances in medical knowledge, because of the research that was done in the past. And what it tells us is that if we keep focused on that research, that we will win the fight to eradicate childhood cancer overall. And so for those two groups of people who are represented here today, and everybody else who's part of this fight, the medical researchers, the doctors, we thank you. Because as Mike said, we are here because of you, and our colleagues are working together on a nonpartisan basis because of you. We need to focus on refining legislation that's been put forward, other creative ideas that come forward from people like Nancy. That's what this is all about. This community here coming up with new ideas for how we can tackle and defeat childhood cancer. That's what we're here for. Now, I am very proud to represent the congressional district that is home to the National Institutes of Health. But I'm even prouder of the incredible work the National Institutes of Health does in so many areas fighting diseases in this country. And we as a nation have to make that investment in medical research. We need it to fight diseases that plague every family. We need to do it because the innovation that spurs is what leads to the development, in many cases, of new drugs that can fight pediatric cancer and other diseases. And right now, I hope all of us will continue to join together to make sure that the United States makes that investment in the National Institutes of Health. Because I can tell you, in recent years, we've actually seen real funding for NIH go down in real terms, has not kept pace with inflation. And in my view, that's a dereliction of duty by the Congress for the country. And so we need to focus on that issue. Now, there's one person at NIH who spearheads the effort. And I can tell you he is, in his field, he is respected without exception by his peers. He is a physician geneticist who served as director of the National Human Genome Research Institute at the NIH from 1993 to 2008. The Human Genome Project successfully sequenced the 3 billion letters in the Human DNA Instruction Book, and it is certainly one of the, if not the most significant scientific undertaking of our time. And the man behind that effort is now the man leading the National Institutes of Health. Before I bring up Dr. Collins, I want to say one other thing about him. because in addition to being a great scientist and an effective leader at NIH, I've had the privilege of seeing his human side. I mean, he's a scientist and he looks at these things objectively from the scientific perspective, but what drives him is how that research will end up helping people like kids with cancer. And just the other night, I had the honor of co-chairing a benefit for something called the Children's Inn. The Children's Inn is a place on the NIH campus in Bethesda where kids are able to stay and have a little shelter from the storm as they undergo lots of different tests for different diseases that are hitting them. And it's an opportunity for those parents and those families to have a warm spot they can kind of call home during very difficult times. And Dr. Francis was there the other night, just as he's been there every single time we've had a benefit to host the Children's Inn. And finally, I just want to say, he's a great guitar player, if you haven't heard him play. Dr. Francis Collins, please welcome.
Well, thank you for such a kind introduction, and certainly thank you from the bottom of my heart, Congressman McCall and Congressman Van Hollen, for your leadership of this caucus. That has meant a lot in raising consciousness about the critical importance of this issue. And thank you, Congressman Kelly, for your support as well. I thought I would say a few words about NIH's perspective on childhood cancer, but I hope also we have a chance for some questions and answers, at least your questions and my attempt at answers. I thought it would also be helpful to say a little bit about where I'm coming from here, and thank you, Chris Van Hollen, for laying out some of that background. Yes, I am a physician. My own research efforts have focused very much on illnesses, many of them quite rare, that had no real understanding and needed to have their molecular basis uncovered in order to be able to do something about treatment. And so in the course of those years as a physician researcher, was involved in the identification of the gene for cystic fibrosis in 1989, and this is an interesting photograph because the little boy on the cover of Science magazine in 1989 is now all grown up and holding that picture himself, Danny Bissett. And of course, if you've been seeing what's happened in cystic fibrosis after 23 of those 25 years being pretty frustrating, now we have, for the first time, effective therapeutics that are looking very promising indeed, based upon an understanding of that molecular defect. But it took a long time, too long. This is a little boy with neurofibromatosis, another disease my lab has been involved in and found the cause of quite a number of years ago, and which is now subject of a significant set of clinical trials at NIH, led by Birgit Wiedemann. And most recently, my lab has been working on a very rare disease where we can only find about 60 cases in the world. Kids with this advanced aging condition called progeria. In this case, this is Sam Burns, who in this picture is 16 years old, one of the kids with this disease who's been incredibly articulate. And in this instance, we were able to go from gene discovery to clinical trial to evidence of benefit in the space of only about 7 years. Sadly, we lost Sam last January to this condition. Now, as the head of the NIH, one of the things that I really cherish is the opportunity to go over to the clinical center, to walk through the pediatric oncology ward, talk to the families, talk to the doctors. You heard about the Children's Inn. One of the things I do with my staff on a regular basis is to bring them over there to cook dinner for the families who are there. And to sit down at the table with a family whose child is there at the Children's Inn, and frankly, most of the time, it's a child with cancer, centers me and any of us who go through that experience in a way that almost nothing else does, about why this is so important and why we have to pull out every possible stop in our efforts to find answers and to come up with ways that are more effective in terms of treating those disorders for which we still don't have answers. My life is sort of paradoxical in that I'm exhilarated by the science that is happening all around NIH's remarkable community of biomedical researchers across the country, across the world. New things are happening almost every day. But still, there are some 7,000 diseases out there, and we still only have treatments for about 500 of them. So we have a long way to go. I can tell you that the scientists I have the chance to work with get it in terms of just how critical it is to push that agenda forward. One of the things that we've tried to do is to make sure that when a basic science discovery happens, and they're happening a lot, that moves as quickly as possible into a translational science approach where you're trying to figure out how to bring that to the clinic and then ultimately to clinical trials, which we hope will succeed. In fact, we started a whole new center, the National Center for Advancing Translational Sciences, just 2 years ago to try to fill in what had been a bit of a less well-defined area, and there was this thing called the Valley of Death, where good ideas sometimes never quite made it across the valley. We don't want that valley to be there. We want to figure out ways to bridge across it. Well, things that I might want to say to you, and I'll try to speak fairly briefly, so I'm going to go through these quickly and not dwell on them, but again, just to state what I think is probably apparent to almost everybody here, NIH has this dual role of both acquiring basic knowledge about how life works, but the application of that knowledge to extend healthy life and reduce illness and disability. We do this, of course, as part of an ecosystem that involves other partners, foundations, advocacy groups like this one, the private sector, biotechnology and pharmaceutical companies, and the health of that whole ecosystem is critical. As I'll come to at the end, our own part of this is struggling a bit right now, and that was alluded to already, just in terms of loss of purchasing power for research. NIH is made up of 27 institutes and centers. One of them you probably know most about, the National Cancer Institute, but I do want to point out that there are activities going on in childhood cancer in other parts of NIH as well, perhaps not as well known. The Child Health Institute, for instance, works on this. NCATS, this Center for Advancing Translational Sciences, does as well. Other parts of NIH that are working on new technologies have applications. But of course it's NCI, which is the main area of focus. And Dr. Varmus, who will be speaking this afternoon, an event at the White House, and I talk regularly about the ways in which we might be able to come up with new approaches to childhood cancer. I don't have to tell this audience that this is still an enormously challenging and difficult situation. The percent of deaths by disease for kids in various age groups, you can see cancer is a dominant force. It is the case that we've seen improvements for all malignant cancers combined here, and you can see from the bars divided up by age groups that over the course of the last 40 years there have been gradual improvements, including in the last few years. Obviously, much of those improvements have been in blood cancers, in leukemias, and we've had less progress to report in other areas, but we have had quite a bit. And this is a way of breaking it down by cancer type, comparing 1977, which is of course a long time ago, and 2010, and even in conditions where we're still struggling, you can see we have made progress for things like soft tissue tumors, brain and other nervous system tumors, but we are still far short of where we need to be. One of the areas that of course needs more study, and which I know people in this audience are very concerned about, is what happens to survivors, all of the things that happen as a consequence of the very aggressive treatments that are used for childhood cancer. And this is a study, the CCSS, which is following 35,000 survivors. Just one example of one of the things they've discovered that now gives us an idea about a better way to manage treatment is that if you're looking at those who develop heart problems, cardiomyopathy, after they've been treated with a particular class of chemotherapy drugs, namely the anthracyclines like adriamycin, turns out that there are variations between all of us in terms of the genes and therefore the proteins that metabolize drugs. And in this case, there's a variant in a gene called CBR3. And if, maybe you can see over there in the diagram, if you happen to have a spelling of that gene, that means that it metabolizes the drug in a different way. the risk of cardiomyopathy can be as high as tenfold elevated. Now that we know that, it's possible to do this prospectively and figure out, well, which are the kids and adults for whom that drug is perhaps particularly one to be very careful of, or to adjust the dose. Just want to say a word about the study of the genome as a way of trying to understand cancer, because this is an area of intense interest, and you'll be hearing, I suspect, more about this from Dr. DePinho when he gets up here to speak shortly. And many of you in this audience are very sophisticated about this, but just to be sure we're all in the same place. Basically, cancer is a disease of the genome. It largely comes about because of misspellings in that DNA instruction book, which guides the activity of cells. And in many instances, that comes about not just because of one misspelling, it's an accumulation of spellings that take a normal cell and ultimately cause it to grow when it shouldn't. There are various types of genes that, if misspelled, can cause this kind of problem. And if you'll forgive me, this is a very simplified cartoon, maybe it's helpful to point out the difference between the two major types of genes that people talk about, oncogenes and tumor suppressor genes. An oncogene is a gene that normally helps cells grow. It's responsible for helping you go from being one cell to being what you are now. A lot of growth has to happen there, of course. But of course, this oncogene should not be activated in the wrong way at the wrong time, and that would be called a step towards cancer. Think of that as the